In 1969, Neil Armstrong stepped onto the moon and spent about 2.5 hours walking around. That was it. A few hours, some samples collected, a flag planted, and then back to Earth. But now, NASA wants to build an actual base up there. Not just visit for a few hours, but live there, work there, maybe even mine resources and use the moon as a launching pad for Mars missions. Sounds simple enough, right? Humans have built cities in deserts, under the ocean, and in the Arctic. How hard could the moon be? Turns out, way harder than you'd think. Because the moon isn't just another extreme environment on Earth. It's a completely alien world where almost everything we take for granted down here either doesn't exist or actively tries to kill you. Let's start with the most obvious problem. There's no air. I know, you already knew that. But think about what that actually means for construction. On Earth, when you need to build something, you just show up with materials and tools and get to work. You breathe. Your machines run. Simple. On the moon, every single person needs a pressure suit just to survive. Every tool needs to function in a vacuum. And here's the thing nobody thinks about until they try it. Welding doesn't work the same way in a vacuum. Traditional welding relies on shielding gases to protect the weld from contamination. No atmosphere means no way to use those gases effectively. Engineers are working on alternatives like electron beam welding, but that requires entirely different equipment and training. And that's just welding. Now imagine trying to pour concrete, operate hydraulics, or use any adhesive that was designed to cure an Earth's atmosphere. Everything has to be completely redesigned from scratch. But lack of air is just the beginning. The temperature swings on the moon are absolutely brutal. During lunar day, which lasts about 14 Earth days, surface temperatures can hit 127 degrees Celsius. That's 260 Fahrenheit, hot enough to boil water instantly. Then, when the sun sets and the lunar night begins, temperatures plummet to minus 173 Celsius. That's minus 280 Fahrenheit, cold enough to freeze carbon dioxide into dry ice. So you're dealing with a 300-degree temperature swing every month. For comparison, the most extreme places on Earth might see a 100-degree swing throughout an entire year. This absolutely destroys materials. Metals expand and contract. Concrete cracks, seals fail, electronics malfunction. Engineers call this thermal cycling, and it's one of the main reasons the lunar modules from the Apollo missions would never have lasted more than a few days on the surface. Any permanent base needs to be designed to handle these temperature extremes constantly, forever. That means new materials, new insulation techniques, and probably burying most structures underground where temperatures stay relatively stable. Then there's the dust. Oh man, the dust. Lunar regolith, which is what scientists call moon dust, is nothing like sand on Earth. It's not smooth and rounded from wind and water erosion. The moon has no wind or water, so the dust particles are sharp, jagged, and incredibly abrasive. During the Apollo missions, astronauts reported that this stuff got everywhere. It worked its way into suit seals, scratched helmet visors, clogged up mechanisms, and was nearly impossible to clean off. One astronaut described it as smelling like spent gunpowder when it got inside the lunar module. Another said it was like trying to work with ground-up glass. And because the moon has no atmosphere, these dust particles also pick up an electric charge from solar radiation. This makes them stick to everything through static electricity. Suits, equipment, solar panels, everything gets coated in this abrasive, clingy dust. For a short Apollo mission, this was annoying but manageable. For a permanent base where people need to work outside regularly, where solar panels need to stay clean to generate power, where airlocks need to seal perfectly every single time, the dust problem becomes life-threatening. NASA is currently developing everything from special coating materials to ultrasonic dust removal systems, but there's no perfect solution yet. Now let's talk about radiation. This one's a killer, literally. On Earth, we're protected by two things: our atmosphere and our magnetic field. These work together to block most of the dangerous radiation from the sun and deep space. The moon has neither. No atmosphere, no magnetic field. just bare rock under a constant bombardment of radiation. Solar radiation is bad enough, but the real danger comes from cosmic rays and solar particle events. When the sun throws out a big coronal mass ejection, essentially a massive burst of radiation, astronauts on the moon would have minutes to get to shelter before receiving a potentially lethal dose. The Apollo astronauts got lucky. They were only on the moon for a few days during periods of relatively low solar activity. A permanent base needs radiation shielding capable of protecting people 24/7 for years. The current plan involves building most habitats underground or covering them with several meters of lunar regolith. But that creates its own problems. You need to excavate, which means heavy equipment. You need to transport regolith, which kicks up more of that terrible dust. And you need to make sure your buried base doesn't become a tomb if something goes wrong. Here's another challenge that doesn't get talked about enough. The moon's gravity is only 1/6 of Earth's. That sounds great, right? Everything weighs less, so construction should be easier. Except lower gravity creates weird problems. Concrete doesn't settle properly. Liquids behave strangely. And the human body starts breaking down. Studies from the International Space Station show that astronauts in microgravity lose bone density and muscle mass incredibly fast. The moon's 1/6 gravity is better than 0 g, but we don't actually know if it's enough to prevent long-term health problems. Nobody's ever spent more than a few days there. There's a real possibility that people living on the moon for extended periods would need artificial gravity systems, probably through rotating habitats. But those are massive, complex, and incredibly expensive to build. And then there's the question of resources, because shipping everything from Earth would cost approximately a fortune. Getting 1 kilogram of material to the moon costs somewhere between $50,000 and $120,000, depending on whose rocket you use. Building even a small base would require thousands of tons of material, so NASA's plan relies heavily on using lunar resources. The technical term is in-situ resource utilization, or ISRU. The moon has oxygen locked up in the regolith. It has metals like aluminum and titanium. There might be water ice in permanently shadowed craters near the poles. In theory, you could extract oxygen for breathing, make rocket fuel, produce building materials, all from stuff that's already on the moon. But all of that requires energy. Lots of it. And generating power on the moon is harder than you'd think. Solar panels work during the lunar day, sure. But that lunar night lasts for 14 Earth days. You'd need massive battery systems to store enough power to last through the night. Or you'd need nuclear reactors, which are heavy, complex, and create their own set of problems. There's talk of putting solar farms at the lunar poles where some crater rims get near constant sunlight. But transmitting that power to a base somewhere else on the moon? That's a whole new infrastructure challenge. So why even bother? If it's this hard, this expensive, this dangerous, why build on the moon at all? There are actually some good reasons. The moon has 1/6 gravity, which makes it way easier to launch spacecraft from there than from Earth. A moon base could serve as a stepping stone for Mars missions, reducing the fuel and cost needed to get there. The moon also has helium-3, a rare isotope that could potentially fuel fusion reactors if we ever figure out how to make fusion work commercially. Some estimates suggest the moon has enough helium-3 to power Earth for thousands of years. And there's the science angle. The moon's far side is the quietest place in the solar system for radio astronomy. A telescope there would be shielded from Earth's radio interference and could detect signals we have no hope of seeing from here. But honestly, the biggest reason might just be that we can. Humans have this tendency to go places and build things just because it's possible. We climbed Everest, we went to the poles, we built the ISS. The moon is the next frontier. The current plan calls for the Artemis program to establish a base camp near the lunar South Pole sometime in the 2030s. They're calling it the Artemis Base Camp. It would start small. A few habitats for 4 astronauts, a rover, maybe a small power station. But the goal is to eventually expand it into a permanent outpost where people rotate in and out on 6-month assignments. Kind of like how the ISS works now. NASA's also working with commercial partners because, let's be real, they don't have the budget to do this alone. Companies like SpaceX, Blue Origin, and others are developing lunar landers and other systems. And there's international cooperation too. The European Space Agency, Japan, Canada, and others are all contributing technology and expertise. But even with all these resources, all this planning, all this technology, we're still probably decades away from a true permanent moon base. The challenges are just that significant. Every problem on the moon is solvable. We have smart people working on solutions. We have better technology than we did in the 1960s. We have more international cooperation and commercial interest than ever before. But solving these problems takes time, takes money, and takes accepting that some of the astronauts who go there might not come back. Space exploration has always carried that risk. The moon isn't going to be conquered quickly. It's going to be a slow, difficult process of building infrastructure, testing systems, learning from failures, and gradually expanding our presence. But if we pull it off, if we actually manage to build a functioning base on another world, that becomes the foundation for everything else. Mars bases, asteroid mining, deep space exploration, all of it starts with figuring out how to live and work on the moon. So yeah, building on the moon is insanely difficult, but it's also the next step in making humanity a spacefaring species. And that's worth solving a few engineering problems for.